So we want to talk about the z-value, which is also called a z-score. They're interchangeable names. The z-value represents the number of standard deviations that a given data value is from the mean. X is that data value. This is your mean, and this is your standard deviation. And you simply plug numbers in and crunch it. But you can also understand it logically. And here's what it's kind of trying to get at, is if your mean is right there, all right, your standard deviations are to the left and right of that. So if we're talking about z-score, we're assuming our mean is 0. And so this is a 1, a 2, a 3. This would be a -1, a -2, a -3. When you're talking z-score, you're talking how many standard deviations. So they're called, your mean would be called kind of like 0. And again, it's 1, 2, 3 standard deviations above, or -1, -2, -3 below. So if I have a z-score of 1.2, 1.2 would be right here. That would be 1.2. If I have a z-score of -0.3, right there, -0.3, somewhere around there. It's how many standard deviations you are from the mean. And you're assuming your mean is 0 when you're interpreting it. Negatives are over here. Positives are over here. Are you going to have many z-scores above 3? Not normally, because there's very, 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 very few values beyond 3 standard deviations. So the normal distribution has a mean of 40 and a standard deviation of 6. What z-value or z-score for a value of 50? So what is the z-value for a value of 50? All right, now I'm going to think about it pictorially, but then we're going to use this formula to calculate it. As a picture, isn't 40 going to be your middle? And then you're going by sixes. So wouldn't this be 46 and this be 52? Now, if we talk of z-values, isn't this 0, 1, and 2? Isn't it 0? Isn't this 0? This is 1 standard deviation. This is 2 standard deviations. Aren't we looking for 50? Won't 50 be somewhere right there? Isn't that about 50? So if we're going to approximate this, can you tell it's somewhere between 1 and 2, really close to 2? Maybe like 1.8 would be our z-score. Now, that is an approximation. If it was a multiple choice test, you could approximate 1.8, 1.7, somewhere around there, maybe. Or you can use a formula to actually calculate it. Our answer should be somewhere close to 2, according to my picture of what's happening. So let's simply now plug in numbers to find it using this formula. So for the formula, we want the z-value, so z equals, x stands for the number you're talking about, which we're looking for 50. Then we minus the mean, which is 40. And then we divide by the standard deviation, which is 6. So that would give us 10 over 6, which if you use a calculator, you will get your answer. So what you get is 1.7 about. It's about. Maybe I should put approximately 1.7 is my z-score, which does that verify according to my picture? Yeah, those kind of agree. Now, this formula does not need to be memorized. You can think of it logically. When you subtract the mean from the standard deviation, aren't you finding the distance to here? Isn't that a distance of 10? And then aren't you dividing by the standard deviation, which is your measuring stick? So what this is saying, I have a distance of 10 from the mean, and I'm dividing it by sixths, or multiplying by 6. How many sixths do I have from 10? And that would be 1 2/3, or 1.7. That's what's really happening. If you think logically, you can throw away the formula. Because what you're really doing is finding the change, that subtraction comes in, which is 10, and dividing by the measuring stick, 6. So that just helps understand the reasoning behind it. For a normal distribution, our mean and our standard deviation. There's our formula, but we actually don't need it for this one, you'll see. What value has a z-score of negative 2.5? So let's think about this. If I have a negative 2.5, well, let's use the picture and see if we can figure this out. If this is 40, and I'm going by 6s, well, isn't negative 2.5 going to be down here somewhere? Halfway between 2 and 3. Exactly, halfway between 2 and 3. All right? And if I'm going by 6s, don't I subtract 6, which would be 34. Don't I subtract again, which would be 28. And then I subtract again to get 22. And aren't we looking for something exactly halfway between? And if you kind of think about numbers, halfway between 22 and 28 is 25. Done. This one you could do by pictures and logic. Exact. Boom. But let's do the formula. Because most of the time, picture's not going to be perfect. We need a formula to guarantee it. So let's get the exact value. Let's use the formula. My z is negative 2.5. My x is what we're trying to find. My mean is 40. My standard deviation is 6. So we're going to solve for x. So I'm going to multiply both sides by 6. That leaves you over here is negative 15 equals x minus 40. Then we're going to add 40 over. So I get x equals 25, which is identical to what we did on our picture. They're the same.